When sodium thiosulfate and hydrochloric acid react, a yellow-white precipitate of sulfur is formed. This change is easily observed and allows us to measure the initial rate of reaction by timing how quickly the precipitate forms. By doing this at different temperatures, we can investigate how the temperature affects the rate of reaction. This picture shows the equipment needed to investigate the rate of this reaction at different temperatures. Your apparatus may differ slightly from mine, but I'll explain why each part is needed as we go through the experiment. Before starting the experiment, you need a table to put your results in. I will repeat the reaction at 5 different temperatures, and each time I'll record the initial temperature of the mixture, the time taken for the reaction to occur, and the final temperature of the mixture. The first step in this experiment is to take a 50 ml measuring cylinder and measure out 10 ml of sodium thiosulfate. I will then add 40 ml of water to form the desired concentration. In your method, you might add less water or none at all if you already have the concentration of sodium thiosulfate that you need. Handle all glassware carefully and wear gloves while handling chemicals. Another safety risk to consider in this experiment is the heat source used. In this experiment, I am using a hot plate. You might use a Bunsen burner or a water bath, so be sure to outline the risks before starting the reaction. Pour the sodium thiosulfate solution into a conical flask and then clamp this flask securely onto your heat source. In this case, I am using a hot plate to control the temperature of a water bath. The next step is to take a 10 ml measuring cylinder and measure out 5 ml of hydrochloric acid. Then pour this acid into a test tube and clamp the test tube securely to the same heat source as the conical flask. Now carefully place a thermometer into the conical flask and let the mixtures equilibrate for a couple of minutes. Once the temperature of the solution has settled, you can remove the conical flask and place it onto a tile or a piece of paper with a cross on. In this case, I did not yet provide any heat to the solution and left it at room temperature. Now add the hydrochloric acid from the test tube and immediately start the stopwatch. Stir the solution gently with a thermometer and record the initial temperature of the solution. In this case, the solution is 18 degrees Celsius. Record this in the table you made earlier. Now that the reaction has started, observe the conical flask from above. I have taken the thermometer out so you can see what's happening, but yours should remain in the flask. Watch as the X disappears. At the moment the cross can no longer be seen, stop the stop clock and record the final temperature of the solution. You should then pour the solution into a stop bath to neutralise the acid and stop the formation of any sulfur dioxide. In your table, record the final temperature of the solution and the time taken for the cross to disappear. Next, measure out the sodium thiosulfate solution and hydrochloric acid into a clean conical flask and test tube, and place these back onto the heat source. This time, add some heat and let the solutions equilibrate for a few minutes. Here I am using a hot plate to add heat to the solution. Another way is to add hot and cold water to the water bath until a desired temperature is reached. As before, Once the higher temperature has settled, place the flask onto the cross. Add the hydrochloric acid, start the stopwatch, stir the solution gently and record the initial temperature. Once the cross has disappeared, stop the stopwatch and pour the solution into the stop bath. Now record the final temperature of the solution and the time taken for the cross to disappear in your table. Repeat the experiment at 5 different temperatures, but be sure that your solution does not exceed 55 degrees Celsius. You should then have a complete table like this. Now that you have your results, you should add 3 new rows to your table. The first new row is the mean temperature of the reaction mixture. This is found by adding the initial and final temperatures of one experiment and dividing by 2. Do this for each of the 5 experiments. The next new row is 1 divided by t, where t is the time taken for the cross to disappear. The final row needed is 1 over t multiplied by 1000. This makes the numbers easier to handle, as you will notice the results for 1 over t were very small. The next step is to draw some axes on some graph paper to plot 1 over t times by 1000 against the mean temperature of the reaction. This picture shows the 2 rows in the table that we will be plotting. This picture shows the graph once the points have been plotted. The graph shows a clear relationship between the rate of reaction and the temperature. As the mean temperature of the reaction mixture increases, so does the initial rate of reaction. The curve is shaped the way it is because a small increase in temperature has a large increase on rate of reaction. This is because the increase in temperature leads to a large increase in the number of successful collisions, which are collisions between particles with the activation energy.